Today we're going to talk about the principal quantum numbers and what they have to do with orbital theory and electrons in atoms. We're going to start with the principal quantum number, also known as n. N, or the principal quantum number, tells you the overall size and the energy of an orbital. And that means that as you go down the periodic table, the n, or size, will get bigger because you're adding more electrons. The numbers that you can use for n are any value greater than 0. So n can be 1 or 2 or 3, etc. After L, after n, we consider L, the angular momentum number. The angular momentum number is a number that tells us the shape of the orbital. And we keep in mind right now that the orbital is where the electrons are, or the shape of where we expect the electrons to be sitting. So we start with n, the size and energy, and then we get L, the angular momentum number, or the shape. And L can be any number that is n minus 1. So if n equals 4, then L can be 3, 2, or 1. Now, you may think, how are we going to keep these from getting confused with each other? And of course, chemists have the answer. For L, we often use letters instead of numbers. So instead of saying 0 is L, we say that L is S. And it is just like that. So we have 0, 1, 2, and 3 as our most common values of L. And we signify those as S, P, D, and F. This will come in handy when you're writing electron configurations later in this course. After L, we consider M sub L, or the magnetic quantum number. And what that tells us is the orientation of the orbital. So let's look at an example to understand what that means. We'll take a p orbital. A p orbital looks like this. It's sort of like an 8 or an infinity sign. And it can look like this, facing up and down like I drew it, or it can look like it's going into the plane or going this way. And all of those exist at the same time in a molecule. So we use the magnetic quantum number to tell us how the orbital looks on an atom. And the values for this are anything that is L, but from negative to positive. So an example of this would be if L is 2, or P, then we would have negative 2, negative 1, 0, 1, and 2 as our options for ML. Lastly, in describing orbitals, we use the spin quantum number. In each orbital, you can hold 2 electrons, and this is pretty complicated, but electrons have a spin. They're each spinning their own unique way. And in an orbital, each electron spins in an opposite way. So your possible ms values are 1/2 or negative 1/2. And this just tells you whether the electron that you're talking about is spinning clockwise or counterclockwise, and whether your L is 1 or 2 or 3 and your ML is negative 2 or positive 2, you can only have negative 1/2 and positive 1/2 as your MS values. So let's look at what this may mean for an example. Let's start with n. If n equals 3, then our possible values for L are n minus 1, or 2. most likely. But we can also have 1 or 0. So there are L values. And then our values for M sub L are negative L to positive L. So let's say that L was 1. It would be negative 1, 0, and positive 1. And of course, M sub S is always equal to negative 1/2 or positive 1/2. Keep in mind that although these are your opportunities, you would only have one if you were talking about a specific electron. So you might have 3, 1, negative 1, and then positive 1/2. And those would be the set of quantum numbers for the orbital and the electron that you are describing in an atom. Just keep in mind when you're facing these types of problems that L is n minus 1, ML is negative L to L, and MS is only negative 1/2 or positive 1/2. And if you need, you can always go and check the textbook for your answers. Good luck, guys!